Next, we'll look at the sum of geometric series. So the formula to find the sum of a geometric series is this. The sum of the first n terms is equal to the first term times 1 minus r to the n divided by 1 minus r. And r, of course, cannot be equal to 1. And r is the common ratio. So let's take a look at some examples using this formula. Find S sub 10 for this geometric series. So notice that in this formula, unlike the one for arithmetic series, is we don't have to know what the 10th term is. We only need to know what the first term is, what the common ratio is, and how many terms we're adding together. All right, so let's go ahead and give this a try. So when we look at this, and we ask ourselves, what are we multiplying by to get the next term? We can see that our common ratio is 1/2, or 0.5. And we're interested in the sum of the first 10 terms. So the sum of the first 10 terms would be equal to our first term, which is 8, times 1 plus 1/2 to the nth power, n is 10, all divided by 1 minus 1/2. And so you could enter that into a calculator and get your answer. Let's take a look at this next example. Find this sum. Let's first of all confirm that it's the sum of a geometric series. So when k is 1, we have 3 times 2, or in other words 6. When k is 2, we have 3 times 4, or in other words 12. When k is 3, we have 3 times 2 to the third, which is 8, or in other words 24. So we can see that this is a geometric series whose common ratio is 2. And we're adding up the first 6 terms. So we're going to find S sub 6. Okay, so according to this formula, we should take our first term, which is 6, times 1 minus r is 2, 1 minus 2 to the 6th, all divided by 1 minus r. And again, we could put that into a calculator, work that out, and that would be the sum of the first 6 terms. Why don't we go ahead and give that a try? So we have 1 minus 2 to the 6th times 6 divided by -1. Okay, why don't you give that a try, see what you get. Okay, hopefully you got 378. That's the sum of the first 6 terms. Here's one for you to try from start to finish. So the first thing you need to do is find out what r is, and we want to add up the first 10 terms of the series. So go ahead and give that a try. Okay, let's check your work. So r is 2. So we want to find the sum of the first 10 terms. And according to the formula, we should take our first term, which is 1/2, times 1 minus r to the n, 1 minus 2 to the 10th, all divided by 1 minus r, which is 2. Okay, and so if we go ahead and work that out, let's just check, make sure we all got the same answer. 1 minus 2 to the 10th times 1/2 divided by -1, we have an answer of 2046. So if we wanted to revisit the chess example, remember the chess example was adding up this set of numbers, 1 plus 2 plus 4 plus 8, every square it doubled, and we wanted to add up the first 64 terms because that's how many that's how many squares are on the chessboard. So it would be equal to the first term times 1 minus 2 to the 63rd, all divided by 1 minus 2. And I think that that might even overflow your calculator memory. It's such a large number. Now, certain geometric series you can add up even if they have an infinite number of terms. And that's what we're going to look at next. this first series, 1 plus 2 plus 4 plus 8 plus 32, you can see that as we're adding this up, and if we kept on going, the terms are getting bigger and bigger, so the sum is getting bigger and bigger. We say a series like this, or a series like this diverges because it just gets bigger and bigger and bigger. But let's take a look at this next example. 1 plus 0.1 plus 0.01 plus 0.001. Let's confirm that this is a geometric series. Okay, well, this is 1, this is 1/10, this is 100th, 1,000th. We can see that it's a geometric series whose common ratio is 1/10. Now notice that as we add on the terms are getting smaller and smaller and smaller. And so eventually they get added on, but because the terms are so small, they don't affect the overall sum of the series. And so the question is, how do we know that the terms are getting smaller and smaller, first of all? And if the terms are getting smaller and smaller, how can we then determine the sum of the infinite series? Okay, so that's what we need to talk about. So the sum of a geometric series, and I should say an infinite geometric series, exists if the common ratio is somewhere between -1 and 1. Because when the common ratio is somewhere between -1 and 1, that means the terms are approaching 0. They're getting smaller and smaller and smaller, and so as you add more of them, it doesn't affect the overall sum. So if we know that the common ratio is less than 0, is between -1 and 1, then we can find the sum of an infinite geometric series by using this formula. The sum will be equal to the first term divided by 1 minus r. Okay, so here are some examples. If the sum exists of this geometric series, find it, and if not, explain why it doesn't exist. So the first thing we have to do is we have to find r for each series. Now this first series isn't even geometric, so this is not geometric because it doesn't have a common ratio. So this one's not going to be geometric, so the sum is not going to exist of the infinite series. This is 1, 1/3, 1/9, 1/27. This is a geometric series whose common ratio is 1/3. 1/3 is between -1 and +1, so this infinite sum will exist. How do we find it? By using this formula here. So S is equal to the first term divided by 1 minus r. So this sum would be equal to 1 over 1 minus 1/3, or in other words, 1 over 2/3. The reciprocal of 2/3 is 3/2. So the infinite sum would be equal to 3/2. Let's try this next one. Or why don't you try this next one yourself? So on this one, we want to see if the infinite series from k equals 1 to infinity, if that's a geometric series. If so, is r between -1 and 1? And if it is, then find its sum. That's what we'd like to do. Okay, so 3 questions. First, is it geometric? Second, what's r? And third, if r is between -1 and 1, find its sum. Go ahead and give those 3 questions a try. Okay, let's check. So let's generate some of the terms in the series. So when k is 1, we have 3 times 3/4 to the first power, or in other words, 9/4. When k is 2, we have 3 times 3/4 squared, or in other words, 3 times 3/4 times 3/4. And the only reason I wrote it this way is because we can see it's 9/4 times 3/4. So in other words, we can see right away that this is geometric. The common ratio is 3/4. because 3/4 is between -1 and 1, we know that this infinite series will have a sum. How do we find it? By using this formula. So the sum is going to be equal to the first term, which is 9/4, divided by 1 minus the common ratio, which is 3/4. So let's go ahead and simplify this. This is 9/4 divided by 1 minus 3/4 is 1/4, and 9/4 divided by 1/4 multiplied by the reciprocal, the sum is going to be equal to 9.